Yes. Hello, everybody. Warm welcome to Holochain-in-Action, a new session. So every Tuesday, community meeting about Holochain, design and architect application, demoing the application that we already have in the ecosystem. It is a session that Philip is here and with a lot of amazing things he's always doing for the community and Holochain. Thank you, Philip, for coming and showing us the great job like always you are doing. So, and if you would like to be in these meetings with your application or idea, just all description you can find in the description in the video. That's it. Thank you, Philip. And let's go to the Philip to see what is waiting for us today, please.
Cool. Thanks, Hidayat. All right, I'm just gonna get straight into a field demo. We'll just start straight up. So let's go hide these controls because that drives me nuts. And I'll hide your smiling faces down there too. All right, so tonight, 3 o'clock in the morning for me, I wanted to show you what we've been building as what we call the Internet of Energy. So you've probably heard about this before, but just wanted to show you the new website. I'm not going to go through it, but essentially this is what it is. We've built a community-driven peer-to-peer trading platform. And I have a bunch of repos here, github.iontech. And what I wanted to do was show you the process of what I did. We really wanted to find a way to capture people's, get them excited about what we're doing, and tried a bunch of different stuff and come up with this idea of building a 3D model of my actual street and putting solar panels on those houses and then making it all work. And working with Unity, that's what's actually happened, because Unity is a game platform. But it also has some really awesome things called assets that you can buy. And so I managed to buy this thing called CityGen 3D, and you literally hook it up to an OpenStreetMap, like so. So this is OpenStreetMap. If you don't know about this, this is the best thing I've found in ages. It's like Google Maps and that sort of stuff, except it's free, it's open source, and you can edit it to your heart's content. So I've actually edited my street and added in all these buildings. And if you go to places like, if we go to Donald, Victoria, which is a town very interested in what we're doing, somebody's actually put in all of the houses for the entire town. So this is really quite detailed information. It's even got tree locations and stuff like that. And so what this means is that us as a community, we can add more and more detail to these OpenStreetMaps. And you'll see on some of these, you actually get more details such as query features. If I click on my house, you can see on the left here that it's got my address, who my neighbors are, and a couple of other bits of information about my house that I put in there. So with CityGen, you can take that information and turn it into a playable first-person shooter kind of 3D environment. So, and the reason I did that was because then I can see the house. I can say, right, if I put solar panels on my house and I sell power to my neighbor, I can see that happening between the houses, and that's what I wanted to build. And that is essentially the Internet of Energy. It's just an accounting system, essentially, for power that is generated and used in your local area. So let's see how it works, eh? I've opened up this thing called a new scene that comes with CityGen. And if we go in here to data, first thing I want to do is give it a name. So we're going to be on Alice Street. Alice Street, Mount Waverley. Just so I can find more of these, because we're going to generate lots of these for all the different locations that we work with. I'm just setting the train size to a 256 meter square block. And I'm going to go and get the latitude and longitude, which conveniently is in the URL on OpenStreetMaps. So I can just drop that in there and get the there. If I set the magnification to about 16 or 17, there's my house there, right? So this block this darker block is the area that's going to get analyzed, and that's about what I want. So you can see all the houses on the street. You'll see that some of them don't have an address. That's because I was experimenting with not filling out all of the details so that you could make this thing a bit more reliable. So what I'll do is I'll download that map now. And you'll see on the left here now, the hierarchy of my game objects now has this CityGen 3D thing, which has downloaded all of OpenStreetMap data. And we'll hit this button here to process it. So what that's doing is that's creating a 2D map of the information. And then we'll load the generator. I know this is a lot to take in, but this is just part of what we're doing, but bear with me. All right, so now that we've got the generator in there, just have to go and fix an issue at the moment. At the moment, the NASA information for the height maps, which is the height above sea level of all the location, that URL doesn't work by default. So we have to go and update it to this other one that does. At the beginning of this one, and have to turn off the lowercase thing. Right. So now that that's done, we can now generate the entire environment. So you can see this is a map it's going to do, and these are all the things it's going to do. It's going to like download the height map. It's going to put highways in and waterways and buildings and roadside objects. So it's really cool. So we'll just go run generator. See, it's done the highways. Now it's doing the buildings. Now it's doing roadside details like lamp poles and stuff like that. And there you go. There's a scene generated. Wow, that was pretty damn quick. So you can have a look around. It's a 3D scene. That's my house there. And that was kind of fun, right? So now you can actually play this as well as a game. So that's what they call a scene environment. And if we run it in the Unity editor, it goes into game environment. And now I can navigate around like a normal first-person shooter. All right, look for all the houses. So we did this, and then I was like, oh, that's pretty cool. And I started putting solar panels on the houses, and I did it all manually. And then I put batteries on the houses, and then I did this thing where the houses were trading and stuff like that. And I was like, yeah, that works. But my God, that was a lot of work to do all that manually. And I discovered that this is another awesome thing that Unity does. You can build your own menus and do whatever you like. So I integrated it into CityGen 3D, and it's called the Internet of Energy Network, right? So now you can go, okay, so in this landscape of all these houses, I want, say, let's say it's a fairly advanced town, because it's my street, so I'm going to make everyone do it. So 75% of the houses on my street are now going to have solar panels. Most of those will have a battery as well. And I'm going to set it up to automatically create three, what we call a supply agreement between two houses. So this is any house will now select three of the other houses that are generating power. So they've got solar as a possible supplier for them. And before we do that, so this is a sequence diagram for how the Internet of Energy actually works, right? So what happens is every period, in this case, we're running 5 minutes because that's what the local Australian energy market operator does. Every 5 minutes, the consumer, which is say my house, goes and finds out how much power I need. So you get that from the meter. You can also get it from my Tesla gateway client as well, which I'll show you a bit later. Then what happens is that the consumer, my house, goes, right, I need to buy some power. And the first thing it does, if you're not generating out power and you need more power, you go and execute your supply agreement, which is basically a contract with your neighbor or whoever you want, people on the street. And you say, right, I'm going to, you and I are going to agree that this is how much I'm going to pay for power when I buy it from you. That's a supply agreement. Then what happens is that I iterate through all of my supply agreements of my neighbors, trying to get as much power as I need for that 5 minute block. Let's say it's 500 watts, right? So I could buy all of it off one neighbor or partial off, or maybe I don't get enough off my neighbors because it's nighttime, which it is now. So that's why I've hacked my Tesla Powerwall to say that it's 8 kilowatts it's generating, even though it's 3 o'clock in the morning for the demo later. But then say if I can't buy power off my neighbors, then I have to go and buy it off the retailer, right? And what we're going to have soon is in here is a community battery option as well. So essentially it's like, I need power. Can I get it off my neighbors? If not, I'll buy it off the retailer. Okay, so let's go back to here. So
really cool, Phil. Really cool.
Yeah. Watch this. This is going to blow your mind. So now I can select the landscape and I say, right, I want 75% of them have solar, batteries, and a number of supply agreements. Done. There you go. Now you can see this new thing called ION. And in the landscape, we just generated a nanogrid for each building. And the reason we called it a nanogrid is because you have the normal power grid. And then lots of people talk about these things called microgrids, which is just a smaller number of houses together. If you get into a nanogrid, that's literally one building. So a nanogrid can be just a consumer of power, or like this one, 58, it has solar panels. So it was one of the 75%. And it also has batteries, and it has 3 supply agreements. So see, I've got a supply agreement there with 56 Alice Street to buy power at 1 ion fuel, etc. So that was all just generated, and you can see the actual solar panels as well. I dropped into the scene, and a battery that's actually inside the house. So you can see that's there as well. So now, if we just jump down to the game manager, you can say, right, so the interval is 300 seconds or 5 minutes. That's where it's going to do the test how much power it needs and try to buy off its neighbors. I put this thing in called time speed factor because this is running in Unity, I can speed it up to the frame rate speed. So as long as my interval, as long as the speed factor still allows enough time for a frame rate to happen, which is on this laptop about 60 frames a second, that's how fast I can speed it up. You can also select the start month, so January in this case, because I want to generate some power. Because what's happening is this model is using data we got from the CSIRO, so which is our Australian Science Authority. And so what they did is they went and analysed a whole bunch of houses. Let's see if we can find it here. Because of course I've got the link, haven't I? Because I nicely credited people. So the CSIRO did all this study of a bunch of different houses and states and times of the year and all that kind of stuff, and they made these nice dashboards. So here, this is all the data. This is from real houses, real meters, all that kind of stuff. So what I've done is I've used this data in my model. So that's a load profile. If you look at the solar panels will show a generation profile as well. For
they offer that through an API, Phil?
Do they? Right.
Do they offer that data through an API?
Do that? I don't know. I decided that what I've tried to do here is the absolute simplest thing I can do to achieve the goal. Then I'll go back and make things smart. So a lot of the times I've coded stuff in because I don't really care about the API yet, if that is available. But what we're going to do is, so there's multiple aspects to the Unity scene, right? And the one I'm going to show you now, this is just the model. So it just uses model data, and you can run it as fast as you like because it doesn't even connect to Holochain. It doesn't do any of that sort of stuff. But the reason we did this one is because what we want to be able to do is size up the amount of solar and storage that you need in an area so that none of the houses ever have to buy retail power. That's the goal. So this is kind of like a consulting and analysis tool. So you can go, you know what, we need more solar. So you can just go back to your landscape and the tool. And integrations. Let's go. That's too much, right? Let's drop it down to 57%. So now there are only 57% of the houses have solar. So it's kind of like a consulting tool, because what I want to do is set it up so to run really fast. And so what I also did was those are load size and solar panel size factors. That's based on the size of the house, like in square meters that you get from CityGen. And I just came up with a factor to make it fit about the right number of solar panels and load. So you can change that as well. And you can tweak all this stuff in the model. So if we run this now, in the console log down here, you'll see all the stuff that's happening. Right, so here you go. So you can see that at that time of day, 63 Ella Street, Mount Waverley bought that amount of power from the power retailer. And then later on in the day, there you go. So this is later on in the day, this house bought from another house, bought from its neighbor, etc., etc. And there you go. And you can see up here the time is changing, 9:47. Let's go a bit faster. Yeah, cool. All right. So now what's happening is that the model is going super duper fast and it's creating all of these records and telling you what's happening. So now that it's 11 o'clock in the day, a lot more houses have come along and are generating enough solar to meet their load so that they can then sell power into the local network. And you can see here that there are 29 nanogrids connected. 15 of them have solar, 9 of them have batteries as well. The load for the entire area is 115 kilowatts. The houses are generating 81 and some of them are storing power as well. So you can see that there's still not enough power being generated in the area to meet the load. So we're going to have to change that. But you can see how fast it's running, right? So every time one of these things happens, that's a transaction between two parties, very similar to the way Holo works, in that when you request data from, when you use a Holo app, the request is served by the Holo network and the person running that Holo port is then paid in Holofuel for that request. Similar approach here. That 0.083 kilowatts of power that this house bought from its neighbor is one of those requests and gets stored as a transaction. And then we'll reconcile that with ION fuel later. All right. So that's good for doing things like working out how much solar we need, how much storage we need, how many community batteries we need, and that sort of thing. It also is really good for testing out the model because nothing's complete without it. So let's go over here. I just want to point out how awesome the scaffolder is again. Thank you very much. So now we're running a conductor. I forced it to run on admin 6500, so I know where it is. And now we're going to connect this model to Holochain. So every time one of these things happens, it's going to record a transaction. Also, the first time around the block, it's going to realize it doesn't, each of these agents hasn't been used before. So it's going to create a new agent for the house. It's also going to install the hApp for the ION protocol so that each of the agents can use it. So before we do that, we're going to have a quick look at what the protocol is, shouldn't we? So it's a bunch of stuff. The ION protocol is 4 DNAs that I come up with. Oh, there's one missing because I haven't done the whole ION fuel yet one. But I had a discussion with Arthur and he said this was a good way to break it down. So you essentially have nanogrid, which is just some settings about the nanogrid, because at the moment, even though we're using Unity to do these things and setting values in here, when we go to the Holochain version, we want to actually store those values in Holochain so that when we make this into a live running WebGL app that can run on the Holo network, then, well, I forgot what I was talking about, doesn't matter. Oh yeah, that's right. So then those values are stored so that then you can say, right, us as a consulting group can build the model, and then we can say, give it to our local Holochain legend, Faye, at the Manningham Council and say, here you go, here's the model that we came up with. This is what we think. You can then give it out to stakeholders and say they can go and change those values and tweak them, right? Change all this stuff, you know, how many solar panels, all that kind of thing, and tweak it in a live WebGL model. So that stuff needs to be stored in Holochain, and that's what the nanogrid is. Then we have energy. So in here, you can have an EcoGrid transaction, which has when it was done, who did the consumption, how much, etc. So very much like a weblog. And same for retail transactions, that's what I've got. And then billing, we're going to have, so this is based on an Australian energy bill where you have a thing called a service charge. That's the connection that you pay to your supplier. And then we're going to have eco-grid charges and retail charges. So you'll see on your bill, you bought this much power from the retailer, which will be us, and you bought this much power from this neighbor, and this neighbor. So there's a very quick rundown of that. As you can see, all built with the awesome scaffolder. Then you have to be able to connect from Holochain, from Unity into Holochain, right? Which is done via a WebSocket using message pack serialization and all that other stuff. It's nasty as hell in C#. I tried it. It's just messy. And I was thinking, well, that's great. You've done all that work in C#, but now no one else can use it except unless they're using C#. But what I wanted was multiple clients to be able to use all of this work. So the idea was, I thought, well, it's a really easy way around this. We just make a socket that I can easily connect to with Unity, just uses normal socket IO to communicate. Then in here, this one is what connects to Holochain using the, where's it? As you want to, using the Holochain client, right? So now I don't have to do any of that horrible message pack serialization and stuff. And I can use common code that everybody can understand in JavaScript. So what this does is it connects to Holochain, allows you to do things like create an agent, install the app, all that kind of stuff. And then you can also create eco-grid transactions and retail transactions. And they're accessed, like I said, through the ION socket. So what that does is it creates a socket connection from the server, not this one, this one. So let's run it. Right, so now we've got a ION protocol socket running, which is now connected to Holochain. So I can now send events down the socket, such as create me a new nanogrid, which will then run this create new agent, which is this function here, create new agent. And that creates agent, and then also goes and creates new nanogrids. So part of creating the agent is also installing the app. So that's why you have all this install admin app bundle. And then you need to get all the cell IDs back and all that kind of stuff. And then when it's finished, it sends it emits another socket back up. So the Unity app is connecting to a normal socket, which is this one. That socket does the event management and the actual socket connection. It is then also connected to Holochain, which has a bunch of common functions in here. Now, the reason that they're in there is because the Tesla gateway client also does exactly the same thing, right? It uses the same set of functions as does the what I call a normal consumer grid, because this one here is just like doesn't have any solar. So I'm just gonna yeah, so what it's doing, yeah, okay, so we're nearly done. Right. Oops. So now we're going to connect this to the ION protocol. So we'll turn that on, and we've now got Holochain running and my socket running. So if we go and run this app now, it's going to go, okay, I need to connect to that socket. If I don't have an agent ID, I'm going to go and create myself one, install the app, I'm going to create a record. And you'll see all that comes up down here, right? So you can see it's now connected to that socket. This is what's going on in the background. It's creating all these agents. I use the address as the installed app ID. It works really well. Right, now you can see they've installed a bunch of apps, each one, and I'll install the apps. Oh, look at that. And so what's happening here is each time an eco-grid transaction is happening, because somebody's buying power off the neighbor, right? That's getting recorded here and saying, so this is how long it's taken to create an entry in Holochain, about 3 to 4 milliseconds most of the time. And that's running at 100 times normal speed, right? So that's doing lots of transactions. And what I found was that doing this bursts, it can, if you can get that bundle moved error if you do these things too fast. So I just come up with it's got to be the simplest message queue you've ever seen. Literally just an array. Wrong one. Socket. Yeah. So all it does is when you create a new, where is it? Sorry, I lost my way a bit there. Word protocol. There you go. Yeah, so it adds it into an array, and then the so you got these arrays. So it does a burst. So you get all these like massive number of emits coming from the UI because it's running at 100 times normal speed. And what it does is it just puts them into an array. And then I just run through the array every 10 milliseconds to see if there's anything there.
So it's basically a buffer, so you can absorb the bursts, right?
That's all I wanted. Yeah, something super simple.
Yeah,
we'll go back and we'll bulletproof this stuff later, but this is how it works. Thank you. Right, so you can see that that's actually working, right? Now that's all great. So now what we've got is the model that we run. Oops. And you can see all this cool stuff. It's all got solar panels on it. It's running at 100 times normal speed, and it's putting in real transactions into Holochain. So my next step is I can now actually do real bills, right? Because we've got all that stuff recorded in the Holo, and so now I can actually make a billing app. So I can actually generate real bills. So what the retailer will be able to do, or what any grassroots organization or any of you guys can do, is go, right, run the model on your local street. Say, right, this is what you get now as your normal system. Once you move to ION Tech, you get, this is your new bill, which will be a lot lower. You could even make money, right? Because I get 6 cents a kilowatt hour from my energy here, which is ridiculous. So that's hardly worth doing. But I'm paying 23 cents. So I can sell my power to my neighbor at anything over 6 cents, and I'm going to make more money, right? So this is why I'm trying to get it done. So now that it's actually going into Holochain and there's real stuff in there to make a billing app from, I can make an actual billing app. So this application now allows you to do a consulting. You can work out like how much storage and generation you need in the area. You can also then work out what level of supply agreements you need. And then you can actually test out the whole thing. So now I've got this thing running at 100 times normal speed, beating the hell out of Holochain, right? That's all done on a model. What I really want to do is I really want to hook up my meter, right? The one that's, I've got a Tesla Powerwall and that kind of stuff. So I want to hook that up to this real system. So we'll just leave that running. I'm going to wing this demo because I haven't done this before. Right. So I have this thing called a Tesla Gateway client that I built, and that's this one. Again, uses the same connection that we've got going before. And I was wondering, like, what we need to be able to do is connect my house, and I'm going to run a socket, and I'm going to have a neighbor, and they're going to every 5 minutes ask me to buy power. But how do I actually connect to my neighbor, right? Because networking is heaps of fun, right? And Holochain has spent a whole amount of effort on solving that problem. They've got this really cool system of, as long as you're on the same DHT, you can message or remote signal anybody on that DHT if you know their agent address. Doesn't matter where they are. It's brilliant, right? Try doing that with like a socket. It's so difficult because you got to get public IP addresses and all this kind of stuff. And I was like, well, how do I get a neighbor to connect to me reliably? So we'll go back to our documentation and tell me if I'm dreaming. Right, so my idea was that the neighbor who's wants to buy power off me turns on their app, which is just another node server. It calls the zone on their DNA. Their DNA then sends a remote signal to me because they've got my public agent key. They send me a remote signal. That remote signal does a local signal emit up to my node client. Right. My node client then goes and gets my public IP address. Did you know about this? You can do this. Curl this one, and it returns your public IP address from outside my home network. Then it calls the zone, sends a remote signal back to my customer, and then they emit a local signal, and they've now got my public IP address, and then they can connect to me. Right. So that's what this is all going to do. Right. Now, am I dreaming? That'll work, won't it? Let's say you were my neighbor and you wanted to connect a socket to me. You need to know my public IP address and the port it's running on, obviously. But if you know my public IP address, you can just do a socket connect directly to that address.
Do you want questions right now, or do you want to keep going and questions after?
Let's just say that that's going to work, and we'll talk about it later. Right?
Yep, that's cool.
Excellent. Right, so now we have my consumer node grid wants to do that, needs to connect to me. And they're going to do the same thing. They're going to connect to Holochain, create themselves an agent, all that kind of stuff. As does my house, which is the Tesla gateway, is doing the same thing. The only reason I separated these two was because, like I said before, I'm trying to make things super simple for the moment. So I'm happy with duplicating a little bit of code, but as soon as it gets too much, it ends up like this, right? It gets extracted. So this house, which is me, is now going to connect to Holochain, create a pub key, install all the apps, and create a nanogrid. Kind of like IOEN did, right? Basically exactly the same. And then what it's going to do is it's going to ping my Tesla Powerball. Tesla Powerball. Oh, login required. Okay, that is the login dickhead. Maybe it's not the password. Anyway. There's always another way around things. Can you guys still see me on the camera?
Yes.
Can you see my phone? No, too hard. Anyway, actually, I know what there you go. IOEN rocks. That's a good password. Right. So let's go back here and put my password in. All right, cool. So you can see here that it's 3:45 in the morning. So I'm obviously not generating any solar power, but that's my load and that's my battery. So you get this nice little API. And so I can hit that Powerwall whenever I want and get these values back. So I can get my instant power. And what that means is that's how much power is going in and out of my meter, not the solar and stuff. So that's net. So I'm using that value. Yeah. So every, what have I got it? I think I've got it set to every 10 seconds at the moment because otherwise it takes too long to watch it happen. It goes and gets my power and sets this thing called available power, available energy. So here we go. So every 10 seconds it goes and hits that, sets my available energy. if there was previous energy from the previous 5 minutes and I haven't sold it to all my neighbors and I haven't used it, no, sorry, I haven't sold it to my neighbors, then I'm just going to stick it in a local community battery, which I haven't got set up yet, but that's the idea. So what happens is every 10 seconds, go and find out how much power I've got available to sell. And then anytime a customer like Guillaume says, hey, Phil, can I have some power? Then I'll work it out and then we'll log it. And this is where we do the transactions. So as you can see, there's a callback here, and that goes back to the customer. And the reason I've got the, where is it on callback? Right, here we go. So what happens is my customer is connected to me and goes, right, I need some energy, and it iterates through the supply agreements. And yeah, it says it'll send to the so it's for each supply agreement here, sorry. You go through and it'll send to the supplier and say, hey, can I have some energy down the socket? And so those sockets will get populated from the IP address stuff we were talking about before. Then when it returns, so it comes back from here, so get the required energy from the thing, goes back and tells you how much that supplier supplied and any energy that you have requirements left. So let's say you needed 2 kilowatts, but that person could only give you 500 watts. You end up with required energy of 1.5 kilowatts because you still need some. So that's why you iterate through. And then it creates an eco-grid transaction, exactly like well, right? So now if we go and run to these, so this is my gateway client. You'll see that I hacked the amount it generates to, here's somewhere, nowhere to go, 8,000 watts, because it's middle of the night, otherwise I wouldn't be able to sell any, right? And so if we go and run this guy, that then connected to Holochain, realized it didn't have an agent ID and created itself one, installed all the apps and came back with the cell IDs. I know this is just the cell ID part of the cell ID, you know what I mean? And now you can see every 10 seconds, it's hitting my solar panels and going, right, how much have I got? I got 8,000 watts from the solar panels that I'm not using in the house. Nobody bought it off me, so I gave it to my local community battery. Get that process? That's just for me, right? Now, Gam turns on his grid, and he's now a customer. So you can see that again, he's a new agent on the network, created himself an agent ID, installed all the apps, and now is connected to 58 Alice Street via the socket thing IP address we just talked about before. Now, the reason we have to do that is because that the value of available energy is debited every time somebody buys some, right? So that has to be a, what do you call it? An oracle number that goes down. So that's why I did it with sockets directly, so that I could keep super accurate track of the available energy, and there was no chance of overselling. So now, okay, so my customer is required 500 watts. He has no required energy left because he bought 500 watts from this agent, and it took 8 seconds. Now that agent happens to be this guy here. So you can see that generated 8,000 watts. I've now got 7.5 left after selling 500 watts to 57 Alice Street. And the rest of it I put into the community battery. This is running on the same DHT as this guy. It was creating 100 million transactions a second. And this is my Tesla client. So every time this guy buys power, is now creating an eco-grid transaction. Now,
try doing that volume on Ethereum.
I can't remember it. I'm just going to remember. I think that's all I was going to show you. Yeah, I'm done. Oh, thank God. So it all works. Nice, eh? Let's all these things down. So I have some questions. So if anybody's got questions, how about we do that now? But I also have some pretty serious questions.
That was amazing. Like the only thing left to do is that if you're in the game and you go to the battery and you actually press a button in the battery in the game, it actually changes in real life.
That's what's going to happen. That's what we're going to do. So I've always had this belief that if you could make work software as much fun as game software, as playing games, that you would have like a super fun workforce who are having a great time and everyone's making a killing. So the part of this process is you start off with the game, and there's all sorts of levels that you can get involved in here, right? You can just be, you could be someone on the street who doesn't know anything about what we're doing, and you could just show them two bills. Go, right, here's before and after. Do you want to pay $400 a month, which I was paying, or do you want to pay $60 a month? It's a no-brainer, right? Then because you can plan the number of solar panels in the area, like down to the last kilowatt, and the amount of storage that you need in the area, you can then set up extremely efficient solar installing processes in your area, right? Because rather than the solar installers coming out doing one house here, one house over there, and then they disappear for 3 months and that kind of stuff, right? If you had 29 houses that you needed to do 75% of the houses on, you need this much storage, and you went to an installer and said, hey, I've got this project for you. You pay about half of what you would pay for an individual install, and it's much more efficient. So then now you've got this impetus to actually go and physically use the game environment to actually connect it to real life, right? That's why I've got the game running and my meter, right? Because it's just perspective on the agent. So now that I've included my meter in the game, it's now gone from being just a simulation and what possibly could be to that's actually what my solar panels are actually generating at that time. And I've actually got that much power to sell to somebody else who wants to come and play the game, right? And then what I also want to do with it is a CO2 map as well. And so you can see the difference in CO2 generation. You can do stuff like, like community batteries, they're up and down the street. And then I was thinking, why stop there? Like, the problem with electric cars, right, is charging the fucking things. They're all going to go, like, what's the one the other day? Oh, hang on, there's a fire at my house. Oh, hang on, we just have to charge up the electric fire truck. Will be 3 hours, right? Like, how's that going to work? And also charging stuff, if you let, like, even people do it, right? You overcharge things and you kill the batteries really quickly. That's why they charge so slowly, because they short out. And generally, people don't use batteries properly. They don't let them discharge properly, or they keep them discharging. You know, they just do what people do. Like, I'm terrible with batteries. But if I could get new batteries all the time, that'd be really cool, right? I wouldn't have a 7-year-old laptop over there that lasts approximately 6 seconds not plugged into power, because it would have a brand new battery. So if I drive my car around to my friend's house and I park out the front of his house and there's a ION battery changing station built into the ground, right? You just literally drive over it, swap the battery on your car. That's the community batteries for the local area as well. So now your one area is charging the batteries, getting put in a car and moving to a completely different part of the state and taking that energy over there, right? So they're actually transferring electrons for you. And then you've got the transfer of value, right? Because you literally pull up out the front of my house, it plugs into the bottom of my car and goes, hey, it's Phil's car. Cool, we're going to charge him this much ion fuel to do a battery swap. Then you've got, I don't know, 10-minute charging. And you always have brand new batteries in your car. And you can have like, you know, like the dairy farmers do, they have the automatic cow detection if they're not feeling well and they get diverted. You know, if you didn't know that, that's what they do. They get diverted off. You do the same with the batteries, like, oh, there's 3 cells dead in that one. Little dude on an electric scooter comes around and it's his job to change the batteries, and you know, it's endless.
So hot swaps instead of charging?
Absolutely.
Yeah. I had a question, so first of all, brilliant demonstration of a bunch of cool integrations, you know, aligned with your vision. So really kudos for that. I was intrigued by this community idea, and you're sharing, you know, sort of community sourcing the power generation. Can you do the same thing with the storage? In other words, you showed storing to community battery, but you know, if they have batteries in there, you know, if they have Tesla walls, it's like I can be a generator, right? So I can also offer the service of storing as well as generating, right? Yeah. Yeah.
So that's why they have batteries. The houses have batteries.
Yeah.
And even though I've been talking about community batteries, when I say storage, it's across the network. So so there is an opportunity for me to install a second Tesla Powerwall and have excess storage that I would never use that I can then sell at nighttime, right?
I think my question is, if my neighbor didn't buy a battery, but did have excess power, could they store it in your battery?
Yeah.
Yeah. So basically you've got decentralized storage and decentralized generation. And you've got bootstrapping it from the ground up in communities.
Yeah.
Beautiful. I love it.
But the thing I really love about this, that's all fun doing the power stuff, right? But the total distribution and complete anarchic thing that happens is that every single house now is running a Raspberry Pi with Holochain running on it, with a 5G aerial, that with a $40 aerial, I can connect to 2 of my neighbors on a mesh network, right? And I've already got a supply agreement with 3 of my neighbors for power. Let's just, cheers, bro. I know your agent ID now. I can literally connect my 5G aerial to your Holochain port, to your Holochain Raspberry Pi. And now you've got solar powered, unenclosable communication.
Awesome.
So you're just bypassing ISPs at that point.
Yeah, imagine that. And not only that, did you know that the Holochain traffic by default will automatically use the mesh network before it uses a normal IP address, like before it goes through a backbone? So now that you've got all your neighbors hooked on Holochain running solar powered ION tech with a 5G network and starting to use all these awesome Holochain apps, that data by default, oh shit, run out of batteries. What did I tell you? That data by default is going to go through the mesh network and not through the backbone.
Philip, first of all, it was amazing. I really, really enjoy seeing everything. Generally, I have a bunch of questions, but in 3 categories. I would like to ask for another session to go further, because my question is, I wrote everything, but I can categorize my question to a story, architect, and technical. It means I really would love to see what kind of a story that we can have. So for example, the agency is a people, or IoT can be kind of agency. It means the devices can we see as a device, as a IoT, and the agency, it means that we can configure the devices that they can go automatically receive energy or somehow automatically do a payment or micro payment. And also I have some question about the architect. So, and then finally a technical question. But if, because I cannot ask all of them right now, but I really would love to have another session, if it is okay, to go more detail about the story, architect, and technical, because right now it was all combined together. So, and I don't know from which point to start, but generally about the IoT, I would select this one for right now. About the perspective, as a game player, as an agent, I can ask what kind of energy and when I'm gonna use, or also I can configure the devices that as an IoT, when you need energy, automatically connect, receive, and with my wallet pay. Am I right? What is the architect? Who is
Almost.
the agency? Who is the agency?
Yeah, you're not actually getting those electrons from your neighbor, because the way it works is that all the electricity goes into a bus. So it's basically a swimming pool. So I put excess energy in and you can take it out. And it, some of it will go shortest route, depending on how it's all configured. But it doesn't really matter, because all you need to know is that I put some in and you took it out. And that's the accounting system. And then same as the way Holo works, is that when you reach a trigger point, then it will trigger an ION fuel transaction like it does with Holo fuel, exactly the same way. And you'll get the same invoicing and all that kind of cool stuff.
And
that's why we're waiting for ION fuel, Holo fuel to be like beta or close enough to being ready, and then we're going to essentially copy it.
And Holoport in the layer of the marketplace is going to play the role, or in the edge layer of the IoT devices? Am I right? It's going to be edge layer?
Holoport, I'm going to use the Holoport for the web app. So there'll be a billing, like you normally get with an energy provider these days, you get a billing app and that sort of stuff. Do the same thing. But that billing app will be running on the Holo so that it's accessible everywhere.
So it means the device to devices is not going to be Holochain. We are going to be a little bit higher level as an edge layer in the IoT, and then Holochain is going to come play.
Holochain is between all the houses. And then you have Holo just for the web app, which will connect to the same DHT. But the web app will be served through Holo.
So in that case, the Tesla as a car, if there is a request, is there anything that how a Tesla is going to be connected to my home? That how
we're not doing anything about cars yet.
Okay, the station.
That's just my battery, the Tesla Powerwall. Yeah.
Yeah, you're not sitting between the devices and either the generation or the battery. You're just dealing with the electricity flowing from generation to battery, right?
Yeah.
Yeah.
Oh no, from generation, from house to house as well. So yeah, it goes into the bus and then it comes out, and that's what the transactions are for. So to be the same.
How a house gets electricity to any of their devices is their business.
Yeah, once inside, once behind the meter, it's none of their business. Yeah. Yeah.
I think I think Phil said he had some serious questions to ask too. We might want to make sure we leave him time to ask his questions.
So the Holochain app is just creates entries. It doesn't do anything else. It's just creating those simple entries. So what I really need help with is now going to the billing system. What's the efficient way now of doing links and querying stuff like that? So I can say, right, out of all those transactions, because what Arthur suggested I do is each month, each billing cycle, which will be monthly or whatever, there'll be a new DHT for the transactions for the next month, so that you don't get these massive monotonic, huge databases. So we'll just about say at the end of the month, we'll it's called digest the transactions into a bill, and that's what will get stored permanently. And then that old DNA will have some sort of like storage time before it's deleted. So you don't have these huge DHTs, because if you're talking about, so the town of Donald with 450 houses making a transaction every 5 minutes with possibly 3 or 4 customers, you're talking about ridiculous numbers of transactions stored for no particular reason after the billing's done, right? I mean, we can keep that. We'll start doing some fraud detection and things like that on that as part of the process of decommissioning those DHTs to make sure that, that sort of stuff. So what I need help with is all that stuff. Plus there's no validation. Also, the customer is the one doing the transaction at the moment. I need some smart Holochain people like you guys to help me understand how do I do validation here? How do we do the Do we need to do countersigning? All that cool stuff that Holochain does, and I'm just literally using it like Mongo.
Cool. Like I'm all up for helping. But it's like it's so open and so many layers and so many things. Do you have any specific problem that you want to start with? So that
Muscle
you can
memory
help.
switching between Rust, JavaScript, Holochain, and C#. All in the matter of like every minute. No wonder Simon's brain gets burned out every day. You only have to.
Yeah, I have to take a rest every day after watching you flip the time.
Yeah, but yeah, GM, that'd be awesome. Because yeah, I need some guidance now, like how to do links. Do we do paths? What's the design of the DNAs to achieve this goal?
Yeah, cool. So I'd say something like, let's start somewhere. Like, let's start with some actual use case. I don't know, maybe the transactions. What do you, oh, sorry.
A little bit increase your volume. Yeah, a little bit.
Wait, this is going
I
to
can hear.
be.
That's good.
Hello.
Yeah,
Hello.
good. I'm telling because of the recording, Philip, somehow in the recording it's really low and it's going to be hard for other people to hear. A little bit is fantastic. Thank you.
Okay, cool. Thanks. So let's see. I guess what's the priority here? Is the priority to understand how to best design the transactions DNA? What specific problem do you want to start with?
Right now, I want to start with the problem of going to bed because it's 4 o'clock in the morning. My leg is killing me. I need some more painkillers. Is the reason I haven't gone to get a battery charger because it's over there. And I can't even. I've literally got knee pads on so I can crawl around the house. It's ridiculous. But I'd love to catch up with you later in the week.
Okay.
And I will have it. You know what? I got a better idea. We'll just do this next Tuesday. Hey? We could do a design session. Holochain-in-Action. Everyone just go nuts, design it, and we'll pair code with some people. Heaps of fun.
I love it.
All right, cool.
And I think can we guys also be a little bit dynamic for a Philip comfort because it is a midnight, maybe a couple of hours sooner that Philip doesn't need to be waking up at midnight. I think we will do it, Philip. So if you can specify the time, all of us can go to
or in about 4 hours from now, like in 3 hours from now would be good for me as well. Even 2 hours.
We will talk in a Discord, but we will try to facilitate it that is less pressure on you actually. And we will find a way. We will go to agreement. Agreement in the finding a good time.
Could you please send the recording to Sim, and Sim, you need to trim it for the demo and stop all that FUD going on with ION. I think it's about time we showed what we've been doing.
I'm gonna asking that if it is okay, we can publish the recording in the Holochain-in-Action YouTube. It is okay as a public. So that's it. Yeah,
I'm happy with that.
Yeah, I will do that.
I think so. You just have to get rid of your password out of it.
Oh no, don't worry about that. That doesn't matter.
Okay.
That's just my gateway, and you can't get to it from here outside the network anyway.
Okay. Is there any sensitive data? So no, cool.
No, for the first time ever, I actually put sensitive stuff in a different document before switching to it. Jeez.
And also, Philip, is there any architect document or a user story document that you can share with others and help us to be ready?
I've written 2 sequence diagrams. That's as far as I got, but I need to start documenting more of it.
One thing I noticed there while you were walking through it is I would really love like an architecture or component diagram of here is the follow port, here is the Raspberry Pi, this connects to a node process, and then this connects to another house. Like I was finding myself building that into my head and saying like, wait, is this house or is this that?
Yeah, totally. So that would be a great idea.
Our architect diagram is fantastic if you can. So even we can help you to make it or generate
Yeah,
it.
absolutely.
So,
That'd be cool. Yeah, like a pair programming session next week would be great.
so if anything else, we can stop recording and continue our conversation. Yeah. So anything else that we would like to be added for the recording? Any question? Anything? That's it. Thank you, everybody, watching this video. For sure, other weeks, we are going to continue this topic, Internet of Energy with Philip. As far as we can do it, we will continue. So thank you, Philip. Thank you, others, for joining. We are going to finish the video recording, and the conversation is going to go to be a little bit, I think, longer. I love you. Take care. Bis nächste Mal.